Hello, this is Anna Griga, and together with Derry Brennan, we will present to you our breast cancer classification project in machine learning. Breast cancer affects more than 2 million women per year and causes the largest number of cancer-related deaths among women around the world. This is why we thought it would be a good idea to focus on this important topic and produce something of value, because an early detection of breast cancer can save lives. The most common form of breast cancer is invasive ductal carcinoma, IDC, accounting for almost 80% of all diagnoses. The scope of this project is to create a breast cancer classification on a IDC dataset that can identify a histological image as benign or malignant using convolutional neural network at first. We have started this project with a lot of research, all documented, and then we moved to finding the data set that we needed. The data set that we'll be using to train and test our program on is the IDC regular data set of histology images from Kaggle, which contains over 270,000 images of breast cancer specimens. Depending on the cancer class, whether benign or malignant, there were assigned prefixes: 0 for benign images and 1 for the malignant ones. The data for the breast cancer classification project was split in 80% for training, 10% for validation, where the model will be adjusted for better accuracy, and 10% for testing, which will be used to provide evaluation of the final model. Using Keras, which is an open source library that provides a Python interface for artificial neural network, a convolutional neural network will be defined and trained on the images from the data set we're going to use. Then a confusion matrix will be derived to evaluate the output of the model. With such a large data set to work, we decided to use Google Colab and store and work with the data. And this was so far our biggest milestone. And Derry will talk now more about the problems we have encountered so far.
Yes, hello. So we've been following the CRISP-DM process model, and at the moment we're in the data preparation to modeling phase. We've been going back and forth a bit on that because initially when we ran our model, it was taking upwards of 24 hours on our local machine CPU. So the decision was made to move to TensorFlow GPU to utilize the NVIDIA GPU available to us. But we've had some problems getting the versions of that working together. When we ran our test on that, we were getting back errors saying that it couldn't find the convolutional library it needed to work with. So we decided then that we'd migrate the project up to Google, move our data set onto Drive and do the computations on Colab. We've had more problems there because migrating the project up there, you just can't drag a whole file structure over. And we had to zip it up and try and unzip it up on Google Drive, but it didn't unzip correctly. Only portions of our project unzipped. So we've had to zip every individual folder up and unzip them all up on Google Drive, maintaining the project structure. But now that they're all up there, we're aiming to have this supervised convolutional neural network model to train within around 95% accuracy. And once the convolutional neural network is up and running, we're going to implement some other algorithms to see which provide the best results overall. So hopefully after Christmas, we'll have a fully trained model to demonstrate. But at the moment, it's still a work in progress. Okay, so thank you. Any questions?